Hello guys, welcome back to the channel. This is the next episode of my Python learning journey. Now that we've mastered Python operators, today we'll explore how machines make decisions using if-else logic. In this video, we will cover the basic if statement, the elif statement for multiple conditions, the else statement, shorthand if, writing logic in a single line, using logical operators within if statements, and finally, nested if logic in the pass statement. Similar to some operators we've seen, an if statement in Python evaluates a condition that results in either true or false. If the condition is true, the code block inside the if statement is executed. If it's false, the code block is skipped. Python relies on indentation, which is the whitespace at the beginning of a line, to define the scope of the code. Without proper indentation, Python won't know which code belongs to the if statement, and the program will throw an error. You can create indentation by pressing the spacebar 4 times, or by pressing the tab button. As you can see here, the age variable satisfies the condition because it is greater than 18. Then, these two lines of code will execute. This line is outside the if statement, so it will execute separately. Let's run this code now. You see, the two lines of code inside the statement executed, as well as the line outside. The statement must have at least one block of code inside it, or it will throw an error. To be further imagining how if statement had worked, let's see this animation. Next, we have the elif statement, which is short for else if. Here I have a simple statement where I use the score variable and a bunch of different conditions to determine which print function should be executed. We have if, elif, and else. You can write an if-elif statement without an else statement at the end, but it doesn't work the other way around. If I delete the if statement here, it throws an unexpected indentation error because an if-elif chain must start with an if. However, if I delete the else statement, it works normally. Now let's run the code. As the score variable is 85, it doesn't satisfy the if statement because it requires a value greater than 90. But we have an elif statement. If the previous condition isn't satisfied, Python moves to the next one. Now I will change the score to 40. You see, because the score didn't satisfy any of these conditions, it falls into the else statement. To understand further, let's see how this code runs. First, it checks the if statement to see if the condition is met. If not, it jumps to the elif statement if one exists. And if even the elif statement isn't satisfied, it jumps to the else statement. Finally, we have the else statement. Think of the else block as the fallback or the catch-all option. It doesn't have a condition of its own because it simply represents everything else. If the if condition is false, and all elif conditions, if you have any, are also false, Python will automatically execute the code inside the else block. It's the final destination when no other doors open. Let's take this as an example. Here I have the age variable set to 15. After that is an if statement for age greater than 18, an elif for age equals 17, and lastly, an else statement. When this runs, the result will be the else block because the age satisfies neither of these two conditions. The result is here. It can be explained further with this animation. After considering the if and elif statements, it runs the else statement last. One thing to remember, the else statement is optional, but if you use it, it must always come at the very end of your logic chain. You can't have an else followed by an elif. The correct order is having else at the end of the block. Now, let's talk about shorthand if, also known as the ternary operator. Sometimes, you have very simple if-else logic that only requires a single action. Instead of writing 4 lines of code, Python allows you to squash everything into one single line. This is great for keeping your code clean, especially when you are assigning a value to a variable based on a condition. The syntax is quite different from the standard version. Since our original if-else statement was assigning a value to a variable called status, we will start with the assignment here. First, we write the value that will be assigned if the condition is met. Then, we write the if condition itself. Finally, we add the else keyword followed by the fallback value. Let's run it. Since the age is 20, the if condition is satisfied, and status becomes adult. But watch what happens when I change it to 13. The else condition is satisfied instead. One quick tip, I only suggest using this syntax for simple if-else statements. If your code block is complicated, don't use this style because it will be difficult to debug and hard to read. Next, let's look at how we can use logical operators within our if statements. In many cases, a single condition isn't enough. You might need to check if 2 things are true at the same time, or if at least one of them is true. This is where and, or, and not come into play. Using and allows you to combine conditions where both must be true for the code block to execute. Using or requires only one of the conditions to be true. And not is used to reverse the result of a condition. This is incredibly useful for real-world logic, like checking if a user has both a valid username and the correct password before granting access. Let's see how it looks in code. Here we have 3 variables and 3 cases to combine logical operators. First, we use the and operator. If both has_high_income and has_good_credit are true, then print eligible for loan. Next, we use the or operator with the has_cash and has_credit variables. If either has_cash or has_credit is true, meaning one or both are true, then print you can make a purchase. Lastly, we will use not. The not operator switches a Boolean variable to its opposite, true to false, or false to true. Here I will use the and operator combined with not. If has_high_income and not has_criminal_record, then print application accepted. The last part is nested if logic in the pass statement. Did you know that you can have multiple if statements inside another if statement? This is called a nested if. Here, the first if statement checks if the age variable is greater than or equal to 18. Inside that statement, I have another one that determines if the has_license variable is true or not. How this code works: first, it checks if the age condition is satisfied. Then it executes the print function and continues to check if has_license is true. However, if the first condition isn't satisfied, it jumps directly to the outer else statement. Next to it is the pass statement. In Python, an if statement cannot be empty. If you haven't decided what code to write yet but want to avoid a syntax error, you simply use the pass keyword. It acts as a placeholder, telling Python, keep going, nothing to see here yet. I have the example code here. In the pass statement, you can highlight a task for later by using a to-do comment, as I've done here. When running this code, Python considers the variable. If it's satisfied, it enters the pass statement and moves on immediately, so the result is blank, as you see here. If I change the variable to false, the result will be inside the else statement. That wraps up today's deep dive into Python's decision-making tools. If you found this helpful, don't forget to like and subscribe to follow my coding journey. Drop a comment if you have any questions. See you in the next one. Happy coding!